Located on a sheep farm in Christiansburg, Virginia, a structure has been arranged to give an alternate audiovisual perception of wind. The structure uses tension acoustic strings to relay the varying wind speeds through the harmonies it plays. The tapered form takes advantage of the Venturi effect to increase the laminar flow of heavy north-south winds on the site. The form of the structure is designed to accept the slope topography and vertically fit within the scale of the trees. The site was chosen for its distance from disruptive noise and open rolling hills for the wind to freely flow. This project aims to bridge a physically distanced world through the innovative collaboration of design, music, nature, and construction. As our realities become more digitally oriented, the permanent structure will provide a tactile connection to the individual's surroundings through the use of acoustics. Enhancing our perceptual understanding of place, time, and space is especially important as our everyday interactions are experienced digitally. The innovative process of collaboration between our group has also in itself discovered new ways of bridging the socially distanced world. In order to safely and successfully complete the project, new ways of communication and construction were adapted. This project is to act as a small-scale precedent for the future of intentional collaborations between architecture, construction, and music, for ourselves and all who are inspired by this project. The creative process consists of various forms of media to understand the project in new ways, while still maintaining the desired design intent. These forms of media include hand drawing, sketching, digital modeling, digital rendering, small-scale modeling, and full-scale detail modeling. Digital modeling was most useful in understanding the measured complexities and how to most easily transfer that to the full-scale structure. The full-scale detail models were also helpful to understand what connections and materials work best while saving time and money. The instrument investigations were a corresponding study through the entirety of the project. This study involved the testing of various string types in which the soundbox materials and forms complemented them. The most successful combinations were a round aluminum soundbox with nylon string and a square steel soundbox with piano wire. The assembly of the instruments were very strenuous, but also worth it to hear the results. In order to remove the natural warping and bowing of wood, an improved column was invented. Each column consists of two 2x4s that are tensioned along their center points with a metal spacer and carriage bolt in between. The columns also serve as a way for the wind to freely flow through the structure. This fabricated column was tested because of one problem, but allowed many other conditions and connections to be improved. The construction process is where the inventive collaboration was most necessary. The wide range of experience within the group created an atmosphere of mentorship and learning. Many students outside of the group were also very helpful during this collaborative process. The first step of the construction was a surveying and leveling of the site. Next, we layered and mortared the ceramic block. Each H block has developed their own patina and impurities and will continue to do so. Vertically, there are gaps between each block on the second layer to allow drainage and prevent cracking in the colder months. Following the block was the pouring and alignment of the concrete piles. Rectangular tube steel was cast into each pile so the columns could be attached without touching the concrete. The videos here were taken after the alignment of the frame and attachment of horizontal supports. Following this, the metal panels are attached to the horizontal supports and the instrument is installed. Here's an audio recording of the final instrument iteration.